Once again, welcome to TOS classes for physics. And today, in this video, I am going to discuss a very important topic, and that is the expression for torque acting on an electric dipole when it is placed in a uniform electric field. Very important question for the purpose of board examination as well as for competitive examination. Let us see how we can prove the how much torque an electric dipole is experiencing. Okay, suppose मैंने मान लिया suppose this is a these lines are parallel to each other and they are equidistant. So these lines will represent an electric field. Which kind of electric field? This is a uniform electric field. So this is uniform electric field. These lines represent uniform electric field. Suppose an electric dipole, I consider an electric dipole is placed like this one. This is an electric dipole and this is an electric dipole, and this makes, suppose this makes and angle theta the horizontal. This is minus q, this is plus q. Okay, so what I consider an electric dipole. You can consider this is point A, or suppose this is point A and this is point B. AB is an electric dipole which has been placed in a uniform electric field. Okay, so I have to write now, suppose what we have considered, suppose AB is an electric dipole of length, its length is 2L, where it has been placed is placed in a uniform electric field. It has been placed in a uniform electric field E, such that it makes an angle theta such that P means electric dipole moment, such that P makes an angle, which angle makes an angle theta. किससे बना रहा है ये एंगल? विद द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. तो ए भी क्या एक इलेक्ट्रिक डायपोल है, इसको हमने इस तरह से रखा हुआ है कि इसका इलेक्ट्रिक डायपोल मोमेंट इलेक्ट्रिक फील्ड के साथ में एक एंगल क्या बना रहा है, एक एंगल थीटा बना रहा है. क्लियर? अब व्हाट विल हैपन? वी नो दैट व्हेन ए पॉइंट चार्ज इज प्लेस्ड इन एन इलेक्ट्रिक फील्ड द फोर्स एक्ट ऑन इट. If the point charge is positive, the direction of electric force is along the direction of electric field. So here, at charge plus q, a force will act. This will be the electric force, and this force will be equal to QE. Direction is along the direction of electric field. Why? Because this is a positive charge, and when a positive charge is placed in a uniform electric field, an electric force acts on it, and the direction of force is along the direction of electric field. Clear? Now we come to the next one. Here minus q, how much force will act on it? This is minus q. The direction of force will be reversed because it is negatively charged. So the picture will be like this one. On plus q charge, an electric force which is equal to QE acts along the direction of electric field, and on minus q charge, an electric force act is equal to QE acts, but this is opposite to the direction of electric field. Okay, so these two forces, they are equal in magnitude, but act in opposite direction, and their line of actions are different. They are acting at different points. So these two forces are known as couple. What they are known as? They are known as couple. And the turning effect of these forces or this couple is known as torque. What is actually a torque? Suppose this is a pen. Okay, if I want to open this pen, then what I will do, you see, I want to open this pen. Clearly you see, from one finger, actually I have to apply the force like this one. You can see this is finger and my thumb, they are acting in opposite direction. This activity you can do at your home also. You can do this activity at your home also. When I have to open the lid of my pen, then I have to apply two forces which are equal in magnitude, opposite in direction. Line of actions are different. It means they are acting at different points. So these two forces are known as couple, and the turning effect of forces is known as torque. Okay, and you have studied in class 11 what is the torque. That from you can write down uh, under the effect of these electric forces, under the effect of electric forces, this dipole tries to align itself in the direction of इलेक्ट्रिक फील्ड. ये डायपोल क्या करेगा, ये इलेक्ट्रिक फील्ड की डायरेक्शन में अलाइन होने की कोशिश करेगा. तो यू हैव टू राइट डाउन अंडर द इफेक्ट ऑफ इलेक्ट्रिक फोर्सेस द इलेक्ट्रिक डायपोल tries, the electric dipole aligns in the direction of electric field. डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. कौन कौन से फोर्स, एक इलेक्ट्रिक फोर्स ये, एक इलेक्ट्रिक फोर्स ये, दोनों इक्वल है मैग्नीट्यूड में, डायरेक्शन अपोजिट है, कपल बनाते हैं. इन दोनों फोर्सेस के कारण क्या होता है, ये डायपोल रोटेट करता है. टर्निंग इफेक्ट ऑफ फोर्स इज नोन एज द टॉर्क. एंड यू हैव नोट दैट द टॉर्क, नाउ द टॉर्क experienced by the torque acting on electric dipole is a well known formula. Magnitude of either force, magnitude of either force multiplied by the perpendicular distance between them. Perpendicular distance between these forces. So I know that how much force is acting. QE force is acting on each charge. Direction are different, magnitude are same. I have to calculate the amount of torque. The expression for the torque experienced by the electric dipole. The definition is, the formula is, or the definition, the torque acting on electric dipole is defined as the product of magnitude of either force multiplied by the perpendicular distance between these two forces. So how we can calculate the perpendicular distance? I have to proceed it in backward direction, and after that I draw like this one in normal. Suppose this is point C. Okay, so like this one. What is the perpendicular distance? The perpendicular distance comes out to be AC, and the magnitude of either charge, torque, is denoted by Greek letter tau. Magnitude of either force I have to write down, that is QE. That is the magnitude of either charge. So from triangle ABC, I can write down AC. AC should be equal to, that should be equal to 2L sin theta. You can see normal upon hypotenuse, that is AC. You can write down here AC upon AB is equal to sin theta, or in next step AC comes out to be AB is equal to 2L, that 2L sin theta. Like this one you will get the expression AC is equal to 2L sin theta. So this you can get from geometry. From geometry we can calculate the distance AC and it comes out to be 2L sin theta. So I can write down the torque experienced by an electric dipole which is placed in a uniform electric field is given by the expression Q2QL, that is equal to P, that comes out to be PE sin theta. So torque, that is the magnitude of the force, magnitude of the torque. So torque comes out to be PE sin theta. So that is the magnitude of the torque that has been acting on an electric dipole which has been placed in a uniform electric field. If I have to write down this expression in vector form, 1 marks question generally asked. So you can write torque is a vector quantity, torque that should be equal to P cross E. So this is the expression for the torque experienced by an electric dipole which has been placed in a uniform electric field. So what we have done in the beginning, we have calculated how much force is acting on each charge. These two forces forms a couple, and due to these two forces, the electric dipole rotate. Turning effect of force is known as the torque, and we know that torque is defined as the magnitude of either force multiplied by the perpendicular distance between these two forces. After that, I put the value magnitude of either force QE and the perpendicular distance from this geometry diagram ABC from triangle. Normal upon hypotenuse, AC upon AB sin theta. So AC comes out to be 2L sin theta. We place the value. I get the torque experienced by an electric dipole when placed in a uniform electric field. Tau is equal to P sin theta. Actually, torque is a vector quantity. So torque is equal to P cross E. What is the direction of torque? That once again the conceptual question. The direction of torque is perpendicular to P, electric dipole moment, and at the same time it is also perpendicular to E. So there are two perpendicular pairs. One pair tau is perpendicular to P, one pair. Second pair tau is perpendicular to E. Very important conceptual question generally asked in competitive examination. Select two pairs of vector which are perpendicular to each other in this expression. I hope that you have understand it well. If you have any confusion, then you can send your comment in comment box. I will try to sort out your problem as soon as it is possible. And do subscribe my channel so that every day you will get my video that is based on physics 12th class and for the competitive examination. Thank you. Have a nice day. Thank you very much.